Going live, going live. Yes. Y'all saw the debate last night?
Yeah.
Between the Swedish chef and Chewbacca? There you go. Oh, goodness gracious. See, the thing is, like, I teach statistics. Which means a lot of the stuff that we end up covering is based on sampling and polling. And at this time of year, this is the biggest time of year for a statistician. Personally, I don't care for yelling and arguing and just going back and forth and political posturing and all that stuff. I personally cannot stand to talk about the concepts of politics. What I would much rather prefer is to talk about the numerical values of polls and predictions and percentages and things of that nature. That is what I'm more interested in, which is why on my personal channel, I will be going live on election night, despite the fact that there might not be a winner on election night. But I'll be going live with my big board and showing all the numbers and calculations. I will have a fun time. I don't know about anyone else. It'll be fun. You just like hang out and stuff. You know, I'll get some soda. You know, I'll look at everyone in the chat and go like, hey. And that'll be like that for 3 hours. It'd be amazing. Anyway, it's during the week that we have off. So you guys can stay up all night. Whatever, you do that anyway. Back to work. Now, ladies and gentlemen, once again, reminder, in Google Classroom, there's the PDF that I'm going to be working on today. You can click that and get a sample of all the questions because you may not be able to see that on the big board up here. Second, there is a project that I have assigned to you, my B-Day classes. Your project will be due Monday, October 12th. You have plenty of time to get that done. As of today, you have approximately 12 days. Usually with a project, I give you guys about a week and a half, something like that. The goal for today is to get used to word problems. I know how much you all loathe word problems. I know how you deal with word problems. When you see a word problem, the typical high school student stares at the word problem longingly, wondering what all these numbers mean, and hopes that if they stare at it long enough, something will make sense. They can pull out the numbers and kind of make it look like they know what they're talking about. Here's the truth, though. I can tell when you don't know what you're talking about. I can tell. I can tell when you're kind of BSing your way through a problem. You can't BS your way through word problems. I'm going to get you past this hang-up of word problems. I told you about last week. I told you about my philosophy of teaching. I told you about the stove and my thumb. Right? Did I tell you about the sandbox? Yeah. The sandbox is what I'm talking about. You got to get your hands dirty. The worst thing that you can do when working on a practice problem is just stare at it and hope that it makes sense. Ms. Murgy, I don't know where to start. Well, how do you start anything? You take a step. You take a step in any direction, and that's how you start. But I might be wrong. Ooh. Yeah, you might be wrong. But take the step anyway. What's the worst thing that can happen with getting a math problem wrong during practice? What's the worst thing that can happen? Am I going to throw a book at your head? I would do that normally. Problem or no problem. You take a shot. Doesn't matter if you make it or you miss. You take a shot. Let's take a look at this worksheet. Bring this up on my big board here. Click, 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 zoom. Focus. Here we go. I want to go through these problems one at a time. Now, the deal with word problems is they are not all created equal. There is no one-size-fit-all strategy for word problems. There's not. Some word problems, you're going to draw pictures. Some word problems, you're going to have to decipher what the heck it's saying by a definition that you just learned for the first time. Other word problems, you're going to have to be a little bit savvy about the trick that they're throwing at you. Let's talk about this first problem. A plot of land, let me kind of fix the screen a little bit. There we go, perfect. A plot of land for sale has a width of X feet and a length of 8 feet less than its width. A farmer will only purchase the land if it measures 240 square feet. What value of X will cause the farmer to purchase the land? Interesting. Do they tell you the shape of the land? Do they tell you the shape of the land? They don't. Can you tell me what you think the shape of the land is? Why? Yeah. Yeah. And they're talking about like area. Square feet is area. Obviously, if you're ever dealing with square feet, you got to know you're dealing with an area. Whereas for the other ones, the regular feet, you're dealing with just the basic length. Square. Okay. Let's draw this thing out. Let's just see what happens. Now I'm going to draw up here in red. Let's just see. A rectangle where one side is measured as X and the other side is 8 feet less. How do I express that? Sure. Deciphering the word problem. The length is 8 feet less than the width. So just subtract 8 from that other measurement. Okay. The farmer will only purchase the land if it measures 240 square feet. Now, you said 240 square feet was area, the area of a rectangle. How does one calculate the area of a rectangle? Going back to your geometry days. Those were the cold days. Length times width. So I got to take the length. I got to multiply it by the width. And that should give me the area? Question mark? Should. What is the area again? Interesting. So here's my setup. Length times width equals 240. There's the setup to the problem. There is the proper setup. Now, we're not at the answer yet, clearly, but that is the proper setup to this problem. Now, there's a bunch of different directions you could potentially go. There's a bunch of different ways that you can solve these types of problems. This is just one way. One way of properly interpreting problem number one. Now, again, like I suggested, you could either put this down on the paper or you could put this down into your notes. That's completely up to you. I'm putting it on the paper just because for consistency's sake. I may put some stuff on the board as well at some point. I haven't really decided yet. But you definitely want to make sure you have this information written down because you may have to reference some of it for the project that you're going to have to do for me. So I got to solve this thing. We've been dealing with quadratics. I don't really see an x squared up there. Ooh, I could simplify some crap. I can simplify some crap up here. Hold on. Sitting down. I could take this, and I could do this. Just do a little distribution action going on there. I get me an x squared minus 8x equals 240. All right, so far so decent. I see the quadratic now, kinda. I see the x squared minus 8x. I think I could try to solve this now. Now, we've been solving by using factoring. We've been solving by using the Tucker method or whatever factoring method you have. I would like to use the Tucker method. What should I do first? Ooh, you did not fall for my trick. Usually when I say Tucker method and what should we do first, you know what most people say? They usually say like GCF, like greatest common factor. But I can't do that yet. I have to get one side equal to 0. You cannot begin the factoring process until you get one side equal to 0. That is the general concept behind solving these things. You got to get one side equal to 0 to find the, quote, zeros of the function. You got to get one side equal to 0 in order to use the zero product property. So I got to write it as x squared minus 8x minus 240 equals 0. Now I can begin trying to solve this. Now, the goal of today is not to really focus on how do you do the Tucker method. I'm going to be reviewing the Tucker method. I'm going to be skimming the Tucker method. Basically, A times C would get you negative 240. I got to find me some magic numbers that multiply to negative 240 and add up to negative 8. Ugh, I got to do that. Yeah, you do. Let's just see what happens. 240 divided by, I don't know, 10. Now, if one of those were negative, the difference is 14. All right. 240 divided by 8. No, I'm getting too far away. The difference between those is 22. 240 divided by 12. Oh, yeah, there we go. The difference between 12 and 20 is 8. Which one has to be negative? Yeah, my two magic numbers are negative 20 and positive 12. See, the thing is, when you're finding your magic numbers, you have to dig a little bit. On this project, you're going to have to dig a little bit when finding these magic numbers. So I got my magic numbers. You could do the T-chart. Technically, the T-chart won't really do anything this time around because the T-chart would be a 1x and a 1x. So I'm going to skip that, and I'm going to go straight here. X minus 20, X plus 12 equals 0. That is where you would take each individual part and set them equal to 0 in order to solve. I do X minus 20 equals 0, and I would get an answer of 20. I would do X plus 12 equals 0, and I would get an answer of negative 12. Yay! Which one works? I got two answers, but I'm telling you right now, one of them doesn't work. Yeah. Well, here, I'm going to be very specific about something. Sometimes a negative answer could work. The reason why this one doesn't, now continue the statement. The reason why negative 12 doesn't work is because what? You can't have a negative length. Now that's the key. That's the key. It's not just because the 12 is negative. It's because when you plug it in here, you can't have a negative length. You can't measure things by saying negative 12 feet. No, you can't do that. So the question is, what value of X will cause the farmer to purchase the land? The only one that works is X equals 20. Which, that's the only thing they really asked. What value of X? I'm going to go a little bit farther. I'm going to go a little bit farther and say 20 feet by 12 feet. I'm just going to go a little bit farther and actually give the dimensions. Because on this project, you're going to have to talk about the dimensions of certain objects. I love me some word problems. This whole day is going to be about word problems. Let's talk about number 2. In business, a break-even point is the point X, Y at which the graphs of the revenue and cost functions intersect. For one manufacturing company, the revenue from producing X items is given by the function Y equals 2X plus 12, and the cost of producing X items is given by Y equals negative X squared plus 10X plus 5. Find all break-even points. Yes?
How do you know the right? Because I put it back in, it's 332.
For this one?
Yeah, if you do 20 times
20 times 12.
Oh, sorry.
Yes, because it would be 12, or it would be 20 minus 8, which would be 12. And then that should give you 240. Question. When I read number 2, at what point did you stop listening to me? No? You all listened to the entire thing? Somebody the other day told me honestly, they're like, Mr. Markey, I stopped listening when you said the word business. Thank you for being honest. No, in all honesty, number 2 is like, what the heck is even going on here? What the heck is a break-even point? Some of you may never have even heard those words put together in that order. Break-even point? What are you talking about? Well, again, diving into the problem, here's what happens. A company sells a product. They get a certain amount of revenue. That's how much money they earn by selling the product. That's their, well, not their profit, but that's their revenue is what they call it. But it costs the company a certain amount of money to make the product. That's how much money they have to spend, the expenses. Revenue minus expenses gives you profit. A break-even point is the moment at which your profit stops being in the red and you actually get breaking even at $0. It's kind of nice. You guys ever hear like those phrases, in the red, in the black? No. When a company is in the red, it means that their revenue is less than their expenses, and they're in the negative dollars. What do you call the Friday after Thanksgiving? Because that's when most companies end up getting out of the red and into the black. That's why they call it that. You just learned something today. Good job. Nobody cares. Anyway, so what do we do with this? The revenue function is given by this fancy linear thing. And the cost of producing items is given by this fancy quadratic thing. You got to find out when revenue equals expenses. You got to find out when this first equation will be equal to this second equation. That is the proper interpretation of a break-even point. That is the proper interpretation of the information that they have given you. What I'm trying to show you is that even though there are a lot of words that you don't want to read, if you took the time to try to understand what they were saying, you would understand that the next step is simply this. Taking that linear and setting it equal to that quadratic. That is logically the step that I need to take. Now, here's the thing. This problem is not equal to 0. You need to get it equal to 0. In a moment, you will. Furthermore, it is in your best interest to keep that A value positive. So I would suggest that when you do this, you move everything over to the left. Once you get it equal to 0, then you are going to begin using the Tucker method or whatever factoring method you know to solve this problem. For number 2, you're going to get 2 answers. Spoiler, they both work. But you need to answer within the context of the problem. So here's what you're going to do. And you in the chat can do the exact same thing. Again, in the chat, if you want to see this problem, the PDF is in Google Classroom. I posted it to the stream. I want you to take the next 5 or so minutes. I want you to complete number 2, and I want you to complete number 4. I'm skipping number 3 because we're going to do that one together. I want you to finish number 2, and I want you to complete number 4. Take the next 5 or so minutes and knock that thing out. Go. For number 4, I would suggest drawing a picture. That would be a good first step, considering what they're describing in the problem. We subtracted 5, right? So why not add the x squared and subtract the 10x? You can move both of those terms. Well, when I said the a value, and then you know how it's always ax squared. Right now it's negative x squared, but if you move it over to the left, it would become positive. Shape that you can draw. It says that the inverse square is increased by 2 and the intercept is decreased by 2. Well, it will be once you change the 2's, right? Here's the thing, you know what the original shape will look like. If you look at the square, if you know what the length of one side of the square was, make an x. You can increase x by 2 as a little bit. Not x squared, that's not increasing it by 2. We just add 2. You're multiplying it by 2. Literally, if you increase something by 2, you're just saying like, oh, it's whatever it was plus 2. If you decrease something by 2, it's just saying, oh, I'm just going to subtract 2. That's what I'm saying to draw the original picture, because here's a little sign of kind of a here we go. Kind of a preview of it. If I say, okay, originally it was x, unknown, but they said increase it by 2. This side, they're like, oh, decrease it by 2. That's the picture. All right. Let's see what we got here. Now, part of your goal, again, is to take some of these quadratics and get them equal to 0. You get them equal to 0, then you can begin solving them. Now, even if the Tucker method were not going to work, then maybe perhaps you would have been stuck using the quadratic formula, which we will be getting into in the coming weeks. There we go. My pen. There we go. There you go. But the quadratic formula is only a last resort. The quadratic formula is only needed if you can't factor, which this one we can. So let's begin moving some stuff around. Now, first, I'm going to add x squared. I am going to subtract 10x. I am going to subtract 5. Once I do that, my right side will be 0. My left side would be x squared minus 8x plus 7 equals 0. That is the proper quadratic that I need for this problem. I'm going to actually show you something on Desmos real quick. Desmos is an amazing website. If you haven't spent any time on it, you should. But we got y equals 2x plus 12, and we got y equals negative x squared plus 10x plus 5. Move up here a little bit, and you can see what the heck is going on here. That red line represents the linear function of revenue. That blue line represents cost or expenses, and they cross each other twice. See if we can't find out where they belong. I'm looking at this problem, and I got to solve it. A times C is 7. What two magic numbers multiply to 7? 7 and 1, but what do they have to add up to? They both got to be negative. Now I'm skipping the t-chart because in this one I didn't really need the t-chart. I didn't need it because it was a 1x and a 1x because of the 1x squared. And I end up with two answers. I end up with an answer of 7, and I end up with an answer of 1. Now the beauty of this is that they both work. They both work. They both absolutely work. Look down here. Click. Look at that ordered pair in the bottom left. 1, 14. How did I get the 1, 14? They're telling me that 1, 14 is that break-even point. Where did the 14 come from? I don't know. In reality, once you see it, it's going to be like, oh, how come I didn't see that before? Where did the 14 come from? Well, think of it this way. Here's an answer of 1. X equals 1 is one of my break-even numbers. If I take that 1 and I plug it in to this equation, 2 times 1 plus 12 is what? 14. That's where that 14 came from. Now look over here at this one. Chapow. 7, 26. Ho-ho. If I take the 7 and I plug it into this question, I get 2 times 7 plus 12, which is 26. Now, I need you to answer this question for me. Why? Why am I giving ordered pairs when I've never given ordered pairs as an answer before? Why am I giving ordered pairs 7, 26 and 1, 14 as my answers when before I've never had to do that? I've never had to. All I've had to do has been like x equals. Why? The break-even point, what form do they take? An ordered pair always takes the form, though, x comma y. But that's what I'm saying. Like, I know you're saying, like, it's a point. It's an ordered pair. It's a point on the graph. The problem specifically said, hey, x comma y, where is it? For these other problems, I didn't have to do that. For these other problems, I did not have to do that. Like the plot of land problem with the farmer. I didn't have to do any of that crap. You only really have to answer what they're asking for. You only have to answer what they're asking for. That's why these two ordered pairs work. The break-even points. Hey, check this out. Look how messed up this is. hold on. Let's say that I ended up with y equals x squared minus 7x plus 8. Now, this was the quadratic that we ended up trying to solve. Wait, was it? No, I'm sorry. I mixed up these numbers. This was an 8 and this was a 7. There we go. Look at those two ordered pairs that I just highlighted at the bottom. Are they the same x values? Yeah, they're definitely the same x values. But they're different ordered pairs because we had this quadratic equal to what? When we were solving this quadratic, what did it equal? It equaled 0, which is what the y value is. 1, 0, 7, 0. It all depends on what the problem's asking. The problem's always going to ask slightly different things. And it's not always going to be done in the same way. Some people might say, that's what I hate about math. That's what I love about math. The fact that it's always something slightly different, and you have to adjust to the situation that is in front of you. You know what that's called? It's called life. Did you know that math is an onion? Math is an onion. Math has layers. Also, math makes you cry. Let's go to number 4. I also had you do number 4. We're going to come back to number 3 in a moment. I suggested to a few people, draw a picture. If the measure of one side of a square is increased by 2, and the other side is decreased by 2, the resulting is a rectangle, blah, 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 blah. Okay, hold on. What are the original dimensions of the square? It's like side by side or some junk like that? A square has 4 equal sides. I don't know what the original measure of the side was. So let's call it x. But it says the measure of one side of the square is increased by 2. Increased by 2. And the other side of the square has been decreased by 2. Decreased by 2. And the resulting area is 32. Which means this setup is very similar to number 1. Very similar to number 1, except the multiplication is going to be slightly more challenging. Now, mind you, they want the measure of one side of the original square, the original figure. They want to know, okay, well, what was the original square? Once we know what x is, if we have x, then we will have it. Because it was some number plus 2, some number minus 2. That x would give me the original square. The square was originally x by x. Have you guys ever been taught FOIL? I don't like it. It's fine if you use it. You could totally use FOIL here. Hurts my teeth. I don't want to mess with it. I prefer the box. But again, you could use whatever multiplication method you know. I prefer the box because this is a 2 by 2 box with an x and a 2 and an x and a negative 2. If I multiply it out within the box, I end up with this junk. That's a negative 4. Whoa, wait a minute. Let me zoom in here. What the heck? What happens here? You jumped. I didn't even point to it. You guys already knew what was going to happen. Yes, the 2x and the negative 2x definitely cancel each other out when you combine like terms. So you end up with x squared minus 4 equals 32. As always, I got to get one side equal to 0. Why does this look weird? Something's missing. What's missing? Ooh, the b value is missing. That term in the middle, the bx, it's missing from the problem. What am I going to assume my b value is? Yeah, you have to assume it's 0x. You have to assume the b value is 0, and that is going to come into play when you are using that Tucker method. So a times c is negative 36. I got to find me 2 numbers, and at this point, I would hope you'd be able to quickly determine that your magic number should be what? Yeah, because they add up to 0 and they multiply to negative 36. The t-chart wouldn't simplify. I'd end up with x plus 6 and x minus 6 equals 0. And I'd get two answers. I'd get an answer of negative 6 and positive 6. But just like number 1, you can't have a negative length. You cannot have a negative length in this problem, which means that the value of x should definitely be 6. So I ask you the question, because it's a word problem, 6 what? What are my units? Ooh, careful. I heard two different things. I heard centimeters and I heard square centimeters. I'm going to tell you it definitely is centimeters. The reason why is because this is just a length of a square. If you're dealing with square centimeters, you're dealing with area. What are you dealing with if you had cubed centimeters? What would cubed centimeters? Say again? No, not perimeter. Perimeter would still be a length. Perimeter would be like just centimeters. Cylinder, kinda. I mean, it could be. Could also be a cube. Could also be a prism. Could also be a pyramid. What are you dealing with if you had cube centimeters? Volume. Volume. Area is always squared units. Volume is always cubed units. It's a strange thing, but that's what it does. Let's go to my favorite problem on this whole page. Number 3. I'm sorry, second favorite problem on this whole page. My favorite problem is number 5. Would you be surprised if I told you all of them were my favorite problem? Yeah. Gosh. It's like you figured out who I am so far. Number 3. Find two consecutive positive integers such that the square of the first increased by 17 is equal to 4 times the second. I'm not interested in that second part right now. I'm interested in that first part. Two consecutive integers. Name me two consecutive integers. Any two. 8 and 9. Cool. 4 and 5. Sure. You can name them all day long. Okay. I was going to say, are you okay? Anyway, back to me. Here's the thing. Two consecutive integers. Do you know what they are for this problem? No. Let's call the first one x. Let's call the first one x. What do you want to call the second one? You could, but I'm not gonna. You could, but I'm not gonna. Ooh, 2x is still not correct. You're not correct, but you're getting in the closer direction. In order to talk about the second number, yes. In order to talk about the second number, you need to use x. Remember all those numbers you just named for me before? You could say, like you said, 49 and 50, right? The first number is 49. So 49 and then 49 plus 1. Two consecutive numbers. This is what you need. This is a problem-solving strategy. If you're ever talking about consecutive numbers, you could always express them like this. This is a strategy that not many people just intuitively know. But this is helpful, incredibly helpful. So now let's talk about this. This is my first number. This is my second number. They're two consecutive integers. Now let's read the rest of the problem. Find two consecutive positive integers such that the square of the first decreased by 17 equals 4 times the second. There is the setup to my problem. That is the proper interpretation. I have a quadratic that I'm going to have to simplify, that I'm going to have to get equal to 0. But that is the proper strategy for this problem. I'm going to distribute. I'm going to get an x squared minus 17 equals 4x plus 4. I'm going to have to get one side equal to 0, which means I'm going to get an x squared minus 4x minus 21 equals 0. Subtract the 4x, subtract the positive 4. That is the quadratic that you end up with. Now I'm going to bypass some stuff. Because there are other things that I need to get to here today. But assuming you did the Tucker method correctly, you would end up with x minus 7 and x plus 3 equals 0. Assuming you did the Tucker method correctly. Negative 7 times 3, negative 7 plus 3. You end up with two answers. Positive 7 and negative 3. Now, I want to be very clear about something. I love me some word problems, but I want to be very clear about something here. If you left it just like this, I'd mark it wrong. Why? Okay. So if this were the answer, it would be 7 and 8, 2/3 to a hilarious joke. And this one would be negative 3, negative 2. If you wrote all of that, if you wrote 7 and 8 and then negative 3 and negative 2, I'd still mark it wrong. Exactly. Reading into the problem. The context of the problem, ladies and gentlemen. Positive integers. Which means, yes, even though negative 3 would work, negative 3, negative 2, even though it would work, it's not the answer. Because they want positive integers. That's it. 2/3 to a hilarious joke. Why is it 2/3 to a hilarious joke? There you go. You know what that's called? There you go. The answer, 7 and 8. Context of the problem. This is how they get you. You know the types of people who come up with math problems just to trick you? They're evil. Evil, terrible people who come up with math problems just to trip you up. I love being one of them. Anywho, let's talk about number 6. I want to jump down to number 6. A guy throwing a rock off a cliff. That's always fun. I want to draw a picture. I love problems like this. The height of a rock thrown off a cliff can be modeled by that equation. All right, fine. Where h is the height in feet and t is the time in seconds. How long does it take for the rock to reach the ground? Okay, hold on. So here's the cliff. Just assume for a moment. That's terrible. I'll just erase that part. There we go. Here's the dude. Down. There's blood everywhere. Assume the rock was ahead. Anyway, the height of a rock thrown off a cliff can be modeled by that equation, where h is the height in feet and t is the time in seconds. How long does it take for the rock to reach the ground? Reaching the ground. What's the height of the rock if I hit the ground? What is? Ooh, interesting. The height of the rock when I hit the ground is 0, which means that h should be 0. Interesting. There's my problem. By the way, you see that cute little tail at the bottom of my T? Do you know why I put the cute little tail at the bottom of the T? Yeah. Sometimes they'll use T, but when I write my T's normally, I don't they look like plus signs. So I put little cute tails on them. This is my problem, though. This is my quadratic. This is what I got to solve. Interesting. I got to solve this sucker out. I got to solve this thing. I think I can factor it. I'm pretty confident that I can factor this problem. Okay. It's equal to 0. Let's start with step 1 of the Tucker method. What's step 1 of the Tucker method? Okay, what's my GCF? 8 is definitely the greatest number I can take out. Yes, it is. It definitely is the GCF. It definitely is a number I'm going to take out in just a moment. I'm kind of hinting at something else, though. I don't like it when my A value is negative. I don't. It makes my life much more difficult when my A value is negative. So I am going to take out an 8, but I'm going to alter it. I'm going to take out a negative 8. Taking out a negative 8 will make my life easier. It's the lazy way out. So let's do that. I'm going to take out a negative 8. I'm going to divide every term by a negative 8, and that is the resulting quadratic. 2t squared minus t minus 15. Now, the beautiful thing about that is the negative 8 will not play a role in my answer. The negative 8 will not play a role. The negative 8's done. It's been divided out. That GCF won't play a role. Let's keep moving with it. A times C, I'm going to deal with what's on the inside of the parentheses. A times C will get me negative 30. I need two magic numbers. I need me two magic numbers that multiply to negative 30 and add up to, what is that in the middle? Negative 1. Ooh, negative 1. Multiply to negative 30 and add up to negative 1. You know how many numbers that multiply to 30? Ooh, negative 6 and 5. Here we go. Now this one I do need a t-chart. I definitely need a t-chart here because it's a 2t squared. And because it's a 2t squared, I got to split it up 2t and 2t. I can simplify that junk. I can simplify it to get, what is this, 1 over 3. And the other one just stays there because it's 2 and a 5. You can't simplify that. T minus 3 and 2t plus 5 equals 0. Now, negative 8 is a factor, but negative 8 will not play a role in the answer. Negative 8 will not play a role in the answer. Instead, I'm going to get an answer of positive 3 and negative 2.5 because you subtract 5 divided by 2. Wait a minute. I'm not dealing with like lengths here. I'm not dealing with like, hey, find the positive answer. That's not what they said. They said, how long does it take for the rock to hit the ground? What would you answer to that question? How long would it take for the rock to hit the ground? 3 what? Seconds. 3 seconds, yes. What the heck is that negative 2.5? What does that play a role in? Where did it come from?
Where it started.
Technically, if you're still holding the rock, how much time has gone by? 0 seconds. If 0 seconds have gone by, if I plug a 0 in here, I get 120 feet off the ground, which is where the dude's at. I don't know how he got up there. Helicopter, rock climbing. Where did the negative 2.5 come from? What shape do all parabolas have? A U shape. What geometric property do they all have? What geometric property do all parabolas have? It's a geometry vocab word. Not to bring back, PTSD memories. When you look in a mirror, what are you looking at? Your reflection. Because you and that reflection, you share symmetry. Every parabola is symmetric. which means there's another half to this parabola. But it's definitely not this one. This is negative 2.5 seconds. How do I know that that's definitely not the answer? Not just because it's negative. Well, yes, but also you're not throwing it backwards. You're throwing it forwards. You're throwing that rock forwards. The height of the rock is thrown off the cliff. Cool. Time is moving forward. You can't time travel back 2.5 seconds. I'm sorry, you can't. There's no way you can do that. Did you know I can time travel? I said there's no way you can time travel back. I can time travel forward. You ready?
Really?
Yeah.
What happened?
No, I'm about to do it for you.
Okay.
Ready?
Yeah.
Boom, 1 second in the future. You just saw it. It's great. What was it? Length, width, and height are the 3 spatial dimensions. Do you know what the 4th dimension is? Time. Einstein said it. Anyway.
Sometimes you really baffle me.
Okay.
Kind of confusing. If you should be a professor, I feel like you could really like teach those kids.
Teach them what? I get to stay here every day and torture high school kids. What better job should I have? College kids are dumb. College kids think that they're too smart for their own good. High school kids know where they stand. Let's talk about a rectangular pool. Now, I'm going to tell you right now, number 7, I'm not going to go over number 7 today. Number 7, I'm going to leave to you as a challenge. It's a challenge. You're not turning anything in. You're not turning anything into me. Just as a personal challenge. What is what? Oh, breadth. Length and breadth. Breadth is an old-timey way of saying width. It's an old-timey way of saying width. I didn't. I cut and pasted. The best teachers are thieves. Yeah. Number 5. Hint. Number 5 might be hint. Important for your project. Hint. In the video that I made for you for the project, I did include a problem about a garden with like a rectangular kind of stone thing around it. It's very helpful. That video is like it explains the whole project. It explains what I expect of you. It explains basically what you have to follow and what you have to turn in. Get them done. Rectangular pool is 20 by 50 feet long. Pool surrounded by a walkway. The walkway is the same width all the way around the pool. The total area of the walkway is 456 square feet. Then the question becomes, how wide is the walkway? Here's what I'm going to suggest you do. First, draw a picture. I'm going to draw the following picture. We're staring at that computer screen a lot. I know, but I'm just saying, you're just kind of staring at it. Also, you had your phone there too. Now, the pool is 50 feet by 20 feet. The walkway is surrounding that pool. We do not know the width of the walkway. We don't. Since I don't know that, since that is the unknown in the problem, I am going to label the walkway width as X all the way around. The width of X. Zoom in, zoom in, and zoom in. The thing that you need to know is that the area of the whole thing equals the area of the pool plus the area of the walkway. Now, I know the area of the walkway. It's 456. What's the area of the pool?
Is it just on the side?
Oh, the area of the pool.
Wait, what's the area then? Length times width?
Yeah.
Yeah.
1,000.
Oh, shoot.
Yeah, there you go.
Oh, no.
It's 1,000 square feet plus 456 square feet for the walkway. Now, yes, I could easily do like equals 1,456. No, that's not what I'm doing. I'm setting up a quadratic. The area of the whole thing. Check this out. This is the most important piece of information you may end up getting today. If I went walkway, this side of the pool, walkway, what is the total height of that thing? If I went walkway, length of that pool, walkway. 20 plus 2x, or 2x plus 20. Yes. I saw what you were going with that, but you were on the right track. And what about the length on the bottom by the same logic? Yeah. Now, mind you, I'm going to write 2x plus 50, but you could write it exactly the way that you just said it. You could still leave it like that because it's perfectly fine. It'll still end up working. 2x plus 50. See, the thing is, the area of the whole thing in this particular instance is 2x plus 20 times 2x plus 50. This convoluted setup is the proper way of handling this problem. This convoluted, kind of icky looking problem. This is the proper way of handling it. The proper setup. Now I'm going to have to multiply those two things together, and I'm going to end up with some sort of a quadratic. And ultimately, when I end up solving this thing down, it's going to give me something of a nice answer. Try to cover that up as best we can. There we go. So let's do that. Let's multiply this junk together. 2x and 20, 2x and 50. What's 2x times 2x? Whoo. And then over here, I got a 40x, and over here, I got 100x, and over here, I got 1,000. I'm going to combine some like terms. 4x squared plus 140x plus 1,000 equals 1456. Ladies and gentlemen, we are on our way. Typically, when you're faced with problems like this, with like a walkway of an equal width all the way around, these are the types of problems that they want you to, or this is the proper way that they want you to kind of knock that problem out. Most of the time, the walkway is going to be a nice length, a decent length, a hopeful length. But this is what we've got here. Let's see. What am I doing right now? What am I doing right now? Or what did I just do with the next step right there? Kinda. I did get all the numbers on one side. Now, technically, you could say I took away 1,000, but what I really did was I subtracted 1456, which 1,000 was kind of knocked out of that. I'm going to take out a GCF. You can pretty much guess what your GCF is supposed to be here. What's your GCF supposed to be? Yeah, it's 4. So I get an x squared plus 35x, yes, minus 114. I'm pretty sure those numbers work. So then, this is the part that I leave to you, because I'm going to end things here. I know we got about 5 minutes left, but I'm not going to finish the rest of this problem because I want you. Take it upon yourself to finish the rest of the problem. I'm not checking these. I'm not asking to collect anything from this worksheet. I'm not asking for any of that. Consider it a little bit of a kind of push yourself moment of, oh, I can do this. I could find those numbers. But again, that's up to you if you want to do that because I'm going to end class here. So a couple reminders. Number one, I am going to be checking Google Classroom for all the stuff that you turned in due time. Obviously, I've been teaching 1, 2, 3 today, so I've had no time to sit down and look over things. Second, the project is live. The project is live. I suggest you don't wait for the last minute. Your project is due Monday, October 12th. I cannot tell you how many students in the past have waited literally the day before or morning of to get that thing done. Please do not be one of those students. Please do not wait until the last minute. Now, a lot of the time people are like, oh, well, I could find all this information. I could easily just copy off my friends and blah, 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 blah. That's cool. That's cool. That's cool because people tend to do that. Keep in mind, even if all of your mathematical work is correct, even if all of your mathematical work is correct and you do nothing else, the best you can get is a 60 on this project. Even if all of your mathematical work is correct, the best you can do is a 60 because there are other things involved in the grading scale. Take a look at it when you get the chance. Make sure you're starting it sooner rather than later. All right, I'm going to sign off. Bell's going to ring in like 3-ish minutes. Chapow.